Features of the ocean floor. The bottom of the ocean. As you walk from the beach into the ocean, the water gradually gets deeper and deeper. Does the ocean floor slope slowly down to the middle of the ocean? Does it stay sandy and smooth, or does the ocean floor have features similar to those found on land? To answer some of these questions, scientists set sail on the British ship HMS Challenger in 1872. The ship went around the world on a voyage that lasted 3.5 years and covered 110,000 kilometers. The scientists made the first major study of the world's oceans. Among other activities, they mapped the depth of the areas of ocean floor. As you did in the investigation, these explorers used a measuring tool that touched the ocean floor. They lowered a weighted rope from the ship. When the rope hung loosely, the scientists knew the weight had reached the bottom. Starting in the 1920s, a new invention allowed more accurate measurements of the depth of the ocean. Scientists began mapping the ocean floor by using an echo sounder. Today, the machine that does echo sounding is called sonar. It works by sending sound waves toward the ocean bottom and finding how long they take to bounce back up to the surface. Scientists know how fast sound travels through seawater. They use this information to calculate how far the sound waves travel from the ship to the ocean floor and back again. Half of that distance is the depth of the ocean floor. Using sonar, scientists have found that around each continent is a gently sloping continental shelf. When you walk into the ocean at an ocean beach, you walk onto the continental shelf. Where the coastline is mountainous, the shelf is narrow. It may extend into the ocean as little as 30 kilometers. Where the land slopes gently to the water, the shelf is usually wider. It may extend as much as 1,100 kilometers into the ocean. Continental shelves are the shallowest parts of the ocean. Their greatest depth is 140 meters. Because they are shallow, they have the greatest variety of ocean or marine life. Most undersea life needs sunlight, which can't reach the ocean bottom in deeper waters. The continental shelf ends at the shelf break. This is the point at which the continental shelf becomes the continental slope. The slope of the ocean floor suddenly becomes much steeper. The continental slope goes down from the shelf break all the way to the deep ocean floor. This is a drop of as much as 4 to 5 kilometers. In some places, steep-sided canyons cut into the continental slope. They stretch for lengths of up to 100 kilometers and have walls as high as 2,300 meters. These underwater canyons are as spectacular as canyons on land. At the end of the continental slope, the ocean floor gradually flattens out into the abyssal plain, the vast floor of the deep oceans. The abyssal plain covers almost 1/2 of Earth's surface. It lies under a layer of sediment, 500 to 1,000 meters thick. The sediment has made the abyssal plain the flattest place on Earth. But on this flat plain are some deep trenches and underwater mountains. This is a new section, the shape of the ocean floor. If you could drain the world's oceans, you would uncover Earth's highest mountains and deepest canyons. The map at the right shows the topography or rise and fall of most of the ocean floor. Along the middle of the ocean floor are mid-ocean ridges. Here the plates of the Earth's crust are being split apart. Molten rock pushed up from below forms new ocean floor and a vast mountain range. The mountains stretch through the Atlantic, Pacific, and Indian Oceans. They rise about 2,500 to 3,000 meters above the ocean floor. As you can see on the map, the mid-ocean ridges extend for great distances on both sides of each split in the crust. As the rocky plates of Earth's crust move apart at the mid-ocean ridges, they push into other plates. Where two plates hit each other, deep ocean trenches form. These trenches are the deepest parts of the ocean. Some of them plunge more than 10,000 meters below the surface. At other parts of the ocean floor, steep-sided volcanic mountains called seamounts rise hundreds or even thousands of meters above the abyssal plain. Researchers have drilled through the sediments on these underwater peaks. Underneath, they have found volcanic rock. This helps to show that seamounts form from molten rock bubbling up from the ocean floor. Most seamounts remain underwater. But as molten rock continues to build them up, some rise above the water surface. The peaks become islands. Seamounts that have become islands are found mainly in the Pacific Ocean. Features of the ocean